Hey everybody, in this video I wanted to talk a little bit about relative rates, or sometimes they're called related rates. And this is how the rates of appearance or disappearance of the reactants or products are related to each other. And this idea of related rates kind of makes just a lot of sense. Okay, so when we get into this, we need to know some of the real basics here. When this reaction, let's use this as our example, and then we'll read what the question asks. But when we have a reaction like this, what we should know is that over time, as the reaction proceeds, the concentration of the reactants will decrease. Okay, so this side decreases, and so it's going to disappear. Okay, now the products, they're being made in the reaction. Because they're being made in the reaction, these guys will appear. And it makes sense that as the reactants disappear, some of the products will appear. Okay, and so how quickly this decreases is directly related to how fast this increases. Okay, so that's where we get the idea of related rates. Okay, now for this question, let me clear this out a little so that we can do this. Okay, so for this question, it says, what is the rate of appearance and disappearance in relation to each other? So for every two of these that we use up, two of these are made. So if two of these are used up, two of these are made, that means that this, I'll write it up here, NOCl, is a 1-to-1 ratio, and so the rate of disappearance of this equals the rate of appearance for NO. Okay, that's because for every two of these being used up, two of these are being made. Now, if we look at chlorine gas here, now for every two of these being used, only one of these is being made. Okay, well, the relationship there for NOCl and Cl2 is that this is going to disappear twice as quickly as this is going to appear. Okay, so this is disappears. Let's see if I can write that. This disappears 2 times the rate that Cl2 appears. Okay. And lastly, if we're going to relate nitrogen monoxide here with chlorine gas, okay, we still have a 2-to-1 ratio. So NO appears at twice the rate that Cl2 appears. Okay, now let me go into a little bit of thing. Let me just real quick. Yeah, okay. So let me show you kind of what this means graphically. Okay, if we were to draw a graph of this, okay, and in a previous video I talked a little bit about graphing concentration. Okay, the concentration of NOCl is going to decrease. It's a reactant, it's going to decrease. And it may not decrease all the way to 0. It may decrease to some other value. Okay, now in red, I'm going to draw what happens to NO. NO is going to increase, and that is going to have the same shape as the NOCl. Why does it have the same shape? Because it's a 1-to-1 ratio. Now, if we look at Cl2, chlorine appears only half as quickly, because you're only making, for every two of these that are being made, only one of these is being made. So this has to increase its concentration just half as quickly. Okay, and so this graph here, if this is Cl2, this is NO, and then the one in black here is NOCl. Okay, this graph shows how the rates are related. Okay, and so this guy and this guy, these two, have the same rate. One is just appearing, and the other is disappearing, and this one is half as much as the NO. Okay, so that's related rate or relative rates, and have a great time with it.